Alright, so this video will focus on 8.2, and on this one we're going to kind of look at the volume of different shapes, including cones. So let's take a look here. Very first what we're going to do is kind of a review of the last chapter, so find the area of the various circles. Again, this is radius squared times pi. So we're going to go through here and figure out all of these radius squares times pi. The only one that's different is, of course, number 4, because that's a diameter. So you have to first divide by 2. So pause the video, try to solve these. Alright, so here are your answers. Notice that it said round to the nearest tenth. Hopefully you did that. If not, you always look to the number after this, and if it's above a 5, you would of course round this number up. If it's below a 5, you'd keep it the same. So what we're going to look for is how do you find the volume of a cone? And there's a really good activity here that I want to kind of show you. And this is called pouring and filling, and I love this thing. So what you do first is we look at the cone, and we look at the cylinder, because we know how to figure out the volume of a cylinder, right? And what I'm going to do is, if you look here, these actually have the same base. The heights are the same. The only thing that's different is the amount of space that it takes up. Do you notice how it goes into this triangular shape? So we're going to see how many of these cones that are the same base and height as this cylinder would take to fill it up. So I go here to fill. Have the nice sound effects. That's 1. That is 2. And finally, it's 3. So I go through here. So the reason why I'm saying this is because if we know the volume of a cylinder, right, we do base times height. If I go in the exact opposite order of what I just did, I know that this cone is 1/3 of the volume of this cylinder. And that's actually the formula if I go through here and solve it. So if I look at like this, for instance, let's take a cylinder here. If I take this one here and if I pretend for a moment that this is actually a cylinder, so I redraw it. Sorry, my cylinders are not the best. But in any case, my radius here is going to be 2 because it says the diameter is 4. And my height is 6. So I'm going to have my 2 times pi times 6. And if I do that, I have 4 times 6 is 24 pi. And I just said before, oh, and this would be units cubed, that this cone is not going to be the whole cylinder, right? It's actually 1/3 of it. So I'm going to take 1/3 of that number. So 1/3 times 24. And in this case, that would equal 24 divided by 3 is 8. So that'd be 8 pi units cubed. And let's look through here and see what the answer is. 8 pi, which is equal to 25.1. So I mean, that's how you'd solve these things. And it's kind of cool because if we already know how to figure out the volume of the cylinder, all the shapes that I'm going to show you, or if you know how to figure out a rectangular prism, they're all super easy if you just think about them as what they are and you don't try to memorize formulas. So we saw before that it took 3 of these to fill up the cylinder. That's why it's 1/3. Let's try another one here where I'm going to go through and I'm going to take a look at like this shape here. This is kind of a weird one with stacks because it looks like it's a parallelogram. Basically how this works, even though it's a slant height or it's a height that goes from here to here, how you'd figure out this formula is exactly how you'd figure out this formula. It's almost like imagine that there's a person here pushing this back over and it would just be 4, so it would be 4 pi times 4. They're both exactly the same in this case. Same with this one here, although it's shifted over like this, it looks exactly the same, just so we know. So it'd just be 9 pi times 5 divided by 3. This would be 9 pi times 5 divided by 3. Same thing. So if it's shifted over, just so you know, it's exactly the same formula as these over here. So what I want you to do is try to apply what we just learned. Try to figure out the volume. So remember, figure out the cylinder and then take 1/3. So pause the video and try to solve these. All right, so the first one is 432 pi. The second one is 64 pi. This one here is about 640 over 3 pi. And this one here is 847 over 6 pi. So you may have something a little bit different. You may actually have like the numbers, which are longer decimals. But this, if you take 640 divided by 3, it might be the same answer that you have if you just had a long decimal. So again, the key ideas are base times height, and then we have to take 1/3 because it takes 3 of these to fill up one cylinder. We did this one already. This is the exact same thing. All it is it's my triangle is turned on its side, or my cone is turned on the side. But let's try solving this because now I have the volume. So I know that I have my 9 So I have 9 squared times pi times height. I have all that times 1/3, right? And then that all equals 956. So the first thing I'd want to do is get rid of this thing on the outside, right? So I can multiply everything by 3. I'd multiply, let's go through here and change this real fast. So I'm going to say times 3, and I'll multiply this side by 3. Just to get rid of this, because this would become 3 times 1 is 3 divided by 3. And now I have 9 squared pi times h equals, now what is 956 times 3? So let's go through here. 956 times 3. I get 2868. So let me just write this down. 2868. Now I want to figure out this right here, so let me change the color. So 9 times 9 is 81 pi times h equals 2868. And now I could take 81 times pi, or I could divide this right here, divided by 81 first of all. Oh, that's a not so nice number, is it? And then I will take that and divide it by pi. And I get this number here. So all I did is I just divided by 81 pi essentially. And I got h equals 11.27, and we'll leave it there. And I could actually run to the nearest tenth by doing 11.28. So these are all the steps that I did. Let's see if we're right. So if I went to 11.27, the nearest tenth, of course, will round this up. So I went to the nearest hundredth here. This would be 11.3, which is the exact same answer. So here's another one. Give it a try. Here's another one. And here are your answers, just so you can study for the test. These are some good examples to look at. So it says here you must, to answer a trivia question before the sand in the timer falls to the bottom, the sand falls at a rate of 50 cubic millimeters per second. How much time do you have? Well, this is a really cool question. I like this, because if you actually figure out how many cubic millimeters you have, you could then divide that by 50 and figure out how many seconds. So take a moment, figure out what this equals, and then press play and see if you got it right. So here's our answer. There's 2,513 cubic millimeters of sand. And to figure out how many seconds, I'd take that number divided by 50, right? And it takes about 50 seconds to fall to the bottom. That's pretty cool. So that's really our lesson for the day. Make sure if you have any questions, you ask in class. Also, I'll put a link to that one video where you could actually play around with shapes to figure out the different volumes.